You're going to hit a ball horizontally with a speed of 40 meters per second. The height is 1 meters above the ground. What distance will it travel before it hits the ground? So the ball is hit initially horizontally, and the horizontal velocity, Vx, will be 40 meters per second. The ball will travel in a parabola, and the vertical displacement is negative 1 meters. There are two other numbers that we know. The acceleration vertical is negative 9.8 meters per second squared due to gravity. And since the ball is hit horizontally right at first, the initial velocity in the vertical direction will be 0. We have three numbers in y: delta y, acceleration y, and the vertical velocity initial. So we have three numbers in y, and we can solve for time. And using the time, we plug it in the horizontal equation. And if we have the Vx, we can solve for delta x. And that is exactly what they want us to solve. What is the distance it travels horizontally? So delta x is the ultimate question. So we're going to choose this equation and solve for the time. So the equation we choose, delta y equals Vyi times the time plus 1/2 a y delta t squared. We plug in numbers that we have, negative 1 for delta y, 0 times the time, plus 1/2, negative 9.8 is the acceleration times the time squared. So that is 0, negative 1 equals, this gives you negative 4.9 when you multiply 1/2 times negative 9.8. We want to solve for the time, so we're going to divide both sides by negative 4.9. And so delta t squared equals negative 1 over negative 4.9. To solve for the time, we're going to take the square root of both sides. And that gives us a value of 0.451 seconds. Next, we're going to take the time and plug it into the x equation. Delta x is Vx times the time. We have Vx is 40. We have time is 0.451 seconds. So delta x, after you multiply that out, is 18.1 meters.